The Hello World sample application has a long tradition in languages that trace their roots to C. In their seminal book that introduced the world to C, The C Programming Language by Brian Kernighan and Dennis Ritchie, the authors used a simple example code that output Hello World, that string, to the default output device to show the basic structure of the language. For posterity, here's that original C code. Had a main method, and then it used the printf function to print out Hello World to the output device. As you'll soon see, C# shares some syntactical features with C, but the programs look quite different. I created the C# version of that classic Hello World program using the console application project template that ships with Visual Studio. So here you have the program.cs file. So this is the main code file for the application. And this contains the complete code for the application. I'm going to be going through the different pieces of the application and use this simple example in order to understand the structure and some of the beginnings part of the syntax of a C# program. Now, it's important to understand that unlike the C version, this C# version is not truly the bare bones code needed to run the program. I'll point out the extra features along the way, but keep in mind that just about all non-trivial applications will need all of these other features, and many more. So this is really more the basis for a real-world application, rather than trying to make an absolute minimalist version of Hello World. The outer block of code in the sample program, ignoring for now the using statement that you'll find at the very top of the code file, is the namespace definition for the code, and it looks like this. This is one of the parts of the sample code that is not strictly necessary. If we didn't include it, the CLR would use a default namespace. But in more complex programs, namespaces bring order and structure to what could be a huge mess. The .NET framework contains many tens of thousands of classes and various other data types and objects. Add to that innumerable objects and third-party libraries that you might use, and everything you define in your program. With all these objects, there are bound to be things named the same, which causes a problem, because if you reference, say, tuple in your code, that's an actual object, do you mean the tuple class that you define in the program, the one in the .NET system.numerics namespace, or one of the other 7 in the third-party libraries that you reference in your project? Okay, that might be a little bit of an extreme, but it shows that name collisions can be a problem. A couple of solutions to the problem would be to use either increasingly long names or give objects gibberish names to keep them unique. Either solution is problematic, though. Long names are burdensome to type every time you need them and make code hard to read and comprehend. And gibberish, random names, are both hard to remember and even harder to figure out what each object is. Short, pithy names that identify what the object is are best in well-written code. Namespaces solve the problem rather neatly by providing an orderly, hierarchical system of categorizing all the objects referenced in your program. And so it's really easy to find different namespaces. You just use the namespace keyword followed by a unique valid C# identifier, such as Hello World, and then have open and closing curly braces, and then you put whatever code that defines the objects that are part of that namespace within those brackets. Now, almost all of the objects in the .NET framework have a root namespace of system. And related technologies that aren't directly part of .NET, the .NET Core, that still come from Microsoft, often use the root Microsoft namespace. A best practice for third-party libraries is to use a root namespace of the company name. So in your programming career, you're likely to encounter namespaces called something like Telerik, or Infogristics, or DevX, and Component 1, which are for the larger companies in that space. And some may use shortened versions of their company names. Any libraries you create for your company that will be shared across applications should probably follow suit. So perhaps if LearnNow went into the .NET component business, we could use LearnNow as the root namespace. Then each program should have its own namespace, or perhaps several if there are various components. So that is why the namespace in the previous code that I showed you is Hello World, which is the name of the program. Now, there's nothing preventing you from using System or Microsoft or any other company's name as the custom namespace name within your own code. These names are not special to C# in any way, so the compiler will happily compile your code as long as there are no name conflicts. But this is a bad practice, because you and other developers will not be able to distinguish the objects from those in the .NET Framework or other Microsoft products. And if Microsoft ever adds objects in those namespaces with names that conflict with yours, your code won't compile or run. So just don't do it. Now, namespaces can be nested, so you'll encounter namespaces like system.data.sql and system.text.regularExpressions. Each period-delimited name drills deeper into the hierarchy. And each of these namespaces at any level could have an object, say, called Floyd, to pick a silly name, without conflicting with other namespaces. Specifically, it would be perfectly okay to have the following objects coexisting. System.Floyd, so have a Floyd object directly in the root namespace. System.data.Floyd, system.data.sql.Floyd, system.text.Floyd, system.text.regularExpressions.Floyd. And your program, in addition, could have a nested hierarchy with lots of Floyd objects as well. For the most part, Microsoft named the namespaces and objects in its libraries with careful thought. So, for example, once you know a little bit about what particular namespaces do, if you encounter the system.text.regularExpressions.regX class, you'll know that the class has something to do with working with text using regular expressions, which is a pattern matching technology if you've not encountered it before, and that the regX class lets you define a regular expression. And you'd be right. Or that system.mail has something to do with sending email across the network. You may not know that it uses SMTP email protocol. It does. But at least you'll have some clue what the class is used for. And you can look it up in the documentation to get the details of what it does and how to use it. So hopefully you're starting to get a feel for how namespaces help you organize code, keep namespace collisions down to a minimum, and then also help you figure out what objects within the framework you want to use. Because as you learn more and more about the .NET Framework, you'll learn that Microsoft has already implemented a lot of the infrastructure sorts of tools that you'll need in your application. So you don't need to reinvent the wheel if Microsoft has already done it. Okay, so every object has a fully qualified name that includes one or more namespace names. So looking at this Hello World code, here are some of the full names of the objects that appear. So first of all, I have the using system. System is the root namespace. I'm using this here as a convenience, so I don't have to keep typing system every time I access one of those objects. And then I have Hello World as the root namespace of this program. So this is an entirely separate namespace. It's separate from system, and it includes all of the objects that I've defined within this application. Now again, keep in mind, this is a very simple program. In a real-world application, say a website using ASP.NET MVC, I'm going to have a whole bunch of different namespaces. Okay, but I have just one in this particular program. All right, and so I also have this program class. Now, because this is embedded within the definition of the Hello World namespace, the fully qualified name of this object is helloworld.program. So this is a class that is contained within the Hello World namespace. And this happens to be the class that includes all of the executable code within this application. All right, I can, once again, have many classes, and a real-world application is going to have many classes that can do all kinds of different things, have different behaviors, store in memory, all kinds of information, and so forth. Simple application, single class. Okay, then within the class, I have this main method that's defined. And so, because this is within the program class, which is within the Hello World namespace, the fully qualified name of main is helloworld.program.main. Okay, and And this also happens to be the entry point into the program. Now, this also brings up where things might get a little bit confusing. Just because you have a fully qualified name that has a bunch of dot-separated names doesn't mean that every one of those names is a namespace. So again, the full name of main is helloworld.program.main, but only hello world is a namespace. Program is a class, and main is a method. Okay, so just keep that in mind. Okay, then within the application, this is the body of the method that actually does the actions, takes the actions that the main method performs. I have this console object. This class lets you interact with the user interface of the console or the command prompt where the program is running. And because the console object is contained within the system namespace within the .NET framework, the full name of console is system.console. And then I call a couple methods of the console object. And so this is the WriteLine method. This writes the output window, and the full name of WriteLine is system.console.WriteLine. And then similarly, I use the read key to keep the window open, waiting for user input, so it just doesn't flash and then the window closes immediately. And the fully qualified name of this is system.console.readKey. Okay, so that's how the different objects are put together relative to the namespace. Probably the most important point is that all of the objects within my custom code are defined within the Hello World namespace, not within the system namespace. System is for the .NET framework. My code is not part of the .NET framework. It uses the .NET framework, but it's not part of the .NET framework. So make sure you understand that distinction. Okay, now a nice thing about using Visual Studio, yet another nice thing, is that you can see an object's semi-full namespace by hovering your mouse cursor over the name in Visual Studio. All right, so I can hover over System. You can see that that's a namespace, System, and it's the root namespace. Hover over Hello World. That's also a root namespace. Hover over Program. Now you can see that the full name is helloworld.program. Now, it doesn't follow that pattern all the way down into different objects. So now if I hover over main, notice that it only displays the name program.main. So it shows what classes it's in and then the name of the method. But I would have to go to program to see which namespace it's part of. And then I can come down here into console and you can see that it's system.console. And because of the support that's built in, the IntelliSense support that is built into the .NET framework, I also get a brief description of what this class does. And so it represents the standard input, output, and error streams for console applications. And then I can hover over WriteLine, and you can see that it's part of the console class, WriteLine, again, along with a brief description of what the class does. Okay, so now notice in the code that I've not needed to use the fully qualified names of any of the objects. I didn't write this as helloworld.program.main. I didn't write this out as system.console. Now, I would have had to use the full name if there had been any ambiguity, such as if we defined a console.WriteLine method in the program that would conflict with the one in the system namespace. I can do that. I can put it in a separate namespace. But if I did that, if it was part of the Hello World namespace, I would have to qualify this. In this case, I'm using the one from the system namespace, so I'd have to write system.console to distinguish it from the console object that's defined within Hello World. Okay, generally I want to try to avoid doing that, but with the thousands of objects, many thousands of objects in the .NET framework, collisions are inevitable. So that's why you need namespaces. Okay, now there are two broad rules at play here. The first is that you generally don't need to use the namespace when you define and use the object within the same namespace. Okay, so that's why I didn't need to use helloworld.program and helloworld.main in the code here. And then the other rule is that for objects from external namespaces that you use often in your code, you can use a using statement like this right here in order to reference the external namespace. That's why my code didn't have to write or didn't have to include system.console.writeLine or system.console.readKey. Okay, now there are other rules and subtleties involved here, but these two rules are enough to get you going at this point in your C# career. Now, the syntax for declaring a namespace consists, at a minimum, of the namespace keyword followed by a valid C# identifier. This is basically the same rules as naming variables. And then it's followed by curly brackets or curly braces, which then encompasses all of the definitions that you want to include within that namespace. And then that means that all of this code, all of the rest of the code of my sample application, is within the Hello World namespace. Now, there are other nested blocks of code for the program class right here, and then the body of the main method. And you'll see many other examples of code blocks like this throughout the course, both because they're an important way to organize chunks of code and because they impact the scope of the objects contained within those blocks. The next major section of the Hello World program is the class, defined by this kind of code. It consists of the class keyword that identifies what sort of object it is, a C# valid name, in this case program, and then again curly brackets that delimit the code that contains everything that's defined within the program class. The class declaration is contained entirely within the Hello World namespace statement, so program is part of that namespace. To wit, the fully qualified name of the class is helloworld.program. Within the class, you can include definitions for fields, methods, and properties, as well as other objects, such as one or more constructors that let you initialize or configure the class when a program first creates it in memory. You'll learn a lot about classes throughout this C# course. They're a fundamental, critical part of building applications within C# and the .NET framework. But for now, you really just need to understand that a class definition is a blueprint for an object that the program will create in memory at runtime. Once the object's in memory, your program code can use the object's properties and fields to store data or bits of information and execute methods to perform whatever actions are useful for the program. Another way of saying all this is that classes combine state and behavior, forming building blocks you can use to model real-world objects. Classes and the resulting objects are the foundation for object-oriented programming, or OOP. And C# supports virtually all of the common features required by OOP, really lacking just multiple inheritance, which is far from a shortcoming of C#. It's a complex feature. This course is not strictly speaking about OOP, but you will learn many of the tools as you learn C#, since it's widely considered an object-oriented programming language. The sole member of this program class is the main method. So that's really the sole reason for the program class to exist. And again, main is the program entry point for the application. I'll talk more about that role shortly. C# doesn't support global methods, so all code that defines behavior has to be defined as part of a class. Now, the simple method is defined as static. I'm not going to get into the details of the static method, but briefly it means that .NET doesn't need to instantiate a program object in memory in order to call this main method. Instead, it can just call the method directly. Now, the method doesn't return anything to the calling program. So in this case, it uses the void keyword to indicate that. Another way of saying the same thing that programmers often use is that the method returns a void, which is a little bit of a contradictory statement because by using void it doesn't return anything, but we say it as it returns a void. Okay, whatever. Many methods do return data, such as a max method that finds the maximum value in a collection of values. The max method returns whatever that maximum value is. All right, and then the main method accepts an array of strings as a single parameter. This lets the code that calls this method pass in information that can change how the method performs its actions. So this string with the square brackets args parameter is standard for a console application, But in this case, the program doesn't make use of this parameter, so you won't see the use of the args variable anywhere within the code. We just didn't need to do that. And then the body of the method includes a couple of comment lines to elucidate what the method does. So those are the statements that are in green in Visual Studio and are preceded by 2 forward slashes. So that's one of the ways that you can indicate comments in a C# program. And the body also includes a couple of statements that interact with the console window. The first statement writes a fixed string. It's delimited with double quotes. You can see right there, so that we know that that's a fixed string. It writes that string to the console window. And then the second statement waits for user input. This latter statement prevents the console window from appearing and immediately closing, a technique that you'll see used throughout this course so you can examine the result of executing the sample code. Okay, so I'm going to go ahead and run the application. And hopefully at this point you're not surprised that the output of this sample program is Hello World. And I even used lowercase in the spirit of that original C version of the program. Okay, so the code that I've explored in some bit of detail now has structural elements that you'll see over and over throughout this course, combined in different ways to build increasingly complex programs. I've mentioned a couple times that the main method of the program class in the Hello World namespace is the program entry point. The C# compiler needs to know where to start execution when you run your program, and the main method is the default program entry point. Now you can change this default location with a bit of work, but doing so is rarely a good idea. Now, whether you use the default entry point or change it, the location has to meet some specific requirements. First, the method that's used for the entry point has to be a static method, so that the CLR doesn't need to instantiate the program object, in the case of the Hello World sample, in order to invoke the method. This is the reason for the static keyword in the definition of main in the sample application. Next, the entry point method doesn't have to return anything. So Hello World's main method returns, using that weird terminology, returns a void, which means it doesn't return anything. You can, however, return an int if you need to return error or status information, usually either like a 0 to indicate success or some negative or positive value to indicate some error condition. And third, the method can accept 0 or 1 parameters. If it accepts a parameter, it has to be an array of strings that contain command line arguments. If it accepts a parameter, it must be an array of strings that contain command line arguments. So you can either include them or just have empty parentheses. All right, so these rules apply to console and other types of .NET projects, but not all. For example, an ASP.NET web application has an entirely different scheme for how and where the execution begins. Although interestingly, with some of the improvements that are coming in ASP.NET, main is coming back. So you'll need to learn different rules as you explore other application types.